looking at my lunch options for today, I looked at the cafeteria menu downstairs on the 8th floor, and I noticed that one of the things on the menu, not today but tomorrow, is what they called world famous lasagna. The first thing I wondered was, what makes that lasagna world famous? The other thing, being an IPC person, is I was wondering if I'd been down the cafeteria maybe 5 years ago, would that have been ordinary lasagna? And then maybe 2 years later it was fairly good lasagna, and then now it's called world famous lasagna. Did they go through an IPC process to get this world famous lasagna? And naturally my mind's working IPC wise, and I figure, well, can we IPC this, I guess? And that is, we have out here is world famous lasagna. I'd write the word lasagna, but I can't spell. And then what do we got here? We've got maybe preparation or raw materials. And what are the raw materials in lasagna? Well, you got some water, and you got some flour, and you got some sauce. Can't spell that either. And then down here you've got the actual baking of it, and you've got time, you've got temperature, and I'm sure there's a zillion other things I could fill in there. I don't know how to bake. But did they go through this kind of process and say, what are the things that make a good lasagna? And then when they were at the point of fairly good lasagna, how did they get from there to world famous lasagna? And what I hope they did is they ran some experiments. They tried some different things. They varied the temperature, they varied the time, they tried a new brand of sauce, and I forgot it's got cheese. Maybe they tried a different kind of cheese. They used Swiss, and then they used Parmesan or whatever, and went through this process. And so maybe to get to this point, they did some experimentation. And what is experimentation in the technical sense of it? Well, what experimentation is, what a true experiment is that it involves three components. It involves the manipulation of what in IPC we call key input variables. What are our key input variables? The water, the flour, the cheese, the sauce, the time, the temperature. Those are key input variables. And we have to manipulate them in a true experiment, vary them in some manner. The second thing we have to do is we have to do this varying in some kind of random order, not haphazard order. And as we go through the day, we'll explain what we mean by haphazard versus randomizing. But did they go through some kind of randomization procedure in making those changes? And the third thing is, when you've done these things, what is the effect on our, in IPC terminology, key output variable, which in this case is world famous lasagna. Now, a true experiment differs from what we call a historic study. I mean, I'm sure there's data sitting around that kitchen on what brand of flour they used and what brand of cheese they used and how long it baked, and we could do a historic study, just analyzing old data. And the difference is, in analyzing historic data, the effect is not one that we planned. We are simply looking at someone else's data on that effect. We didn't measure it. We don't know how they measured it. I'm sure no one kept records on whether the pizza was world famous or not. So the effect is one that we don't have control over. Manipulation. There was no manipulation. They ran out of Heinz sauce, so they bought Hunt's. And I'm sure nobody bothered to write it down. There was no planned manipulation. It was all an accident. And the randomization was random. Nobody planned to do anything. When they ran out of this, they picked up that. If the oven wasn't working too good, they jacked the temperature up. There was no planning to it. So a historic study involves no planning of that effect, no manipulation, and no randomization, as opposed to a true experiment. What are then the steps in doing a true experiment? There's really three steps we're going to talk about: the experiment, the design, and the analysis. Let's start with the experiment. First is what sounds kind of stupid, and that's what is the problem? What are we trying to achieve? What we're trying to achieve is, going back to this page, world famous lasagna. Now, that's our problem. We want world famous lasagna. So our dependent variable is world famous lasagna. How do you define it? What does that phrase mean? And who makes the definition of world famous lasagna? Now, we don't run pizza, we make steel. What makes good steel? Does the customer decide that, Jack?
Absolutely.
And is it the same for every customer? When you reject a coil, Gordy, does every coil get rejected for the same number of slivers? Or does it differ by customer?
Yeah.
So the statement of the problem and the choice of a dependent variable isn't as simple as it sounds. What is our problem? So when we're doing an experiment, sometimes we have to look a little more closely, and maybe we can't use percent slivers or rejections for slivers as our variable. We may have to invent a new variable. We may need to do some extra studying and some extra data to get the exact dependent variable to really get our choice of a problem. What are our independent variables? Well, I listed a whole bunch of them here. Some of them are going to be constant, and some of them will be manipulated. And it's important to take into account every one of these variables and not forget any. If you're going to manipulate these three, you better know what you're going to do with those three. Either hold them constant or manipulate them. Don't leave them to chance. And we'll get into a great deal of detail on how many of these variables can be varied simultaneously. Get to the end of this class, you'll find out that 1, 2, 3, 4, 5, 6, that you can vary as many as 7 variables in 8 experiments. A lot of hazards in that, but it can be done statistically. 7 variables, 8 experiments. And finally, choice of levels. We're going to vary time. How many times? Run it at 30 minutes and then 40 minutes? You're going to run it at 30, 35, and 40 minutes? How many different levels are we going to do? And that depends on a couple of things. The most obvious being, is it linear? If the effect on whatever we call good lasagna, if you go from 30 minutes to 40 minutes, is that a linear effect? If it is, all you need is 2 data points. There are some processes that look like that. And then you need 3 levels of the variable. So the choice of levels depends on linearity or non-linearity of your process. The second phase of an experimental process is design. And that starts out with, how many experiments do I run?
2 minutes.
2 minutes? As a statistician, the more the merrier. As a practical person who realizes what the operators have to deal with, I recognize that's not always possible. And so you have to draw a balance between the number of experiments that is statistically important and the number of variables that to an operator are practical to run. And we'll learn in this course what those trade-offs are. I mentioned the 7 variables in 8 experiments. From an operator standpoint, that's super. From a statistical standpoint, that's got some problems. And we'll deal with what those problems are and how you get around those problems. Order of experiment. fully randomized or restrictions on randomization. If I'm going to run an experiment and I'm going to put lasagna at different baking times and different baking temperatures in ovens, real live ovens, I'm restricted in how many things I can do in that oven. And I obviously can't change, if I'm going to put 2 lasagnas in there, I'm going to bake one for 30 minutes and one for 40 minutes, I obviously can't bake them at 2 different temperatures. They're in the oven at the same time. So there are times when randomization sounds good, but I may need some restrictions on randomization. And we'll get into how you handle that. And finally, interaction. The most complex and most difficult of all concepts, and yet the most important.
1 minute.
Never make it. Is it possible that if you run at 2 different temperatures for 30 minutes, the effect on lasagna is good? The lasagna gets better. If you run it at a higher temperature and now change the temperature for 40 minutes, things get worse. This is interaction. That greatly affects how we run an experiment and is probably the most key element that we have to consider. And, this goes on.
Okay.